Awesome. Yeah, so hope you all can see my screen. Thanks for those who are joining live today, as well as folks who will be, watching this session later on. This is Multimodal Weekly, a virtual webinar series hosted by the team at TwelveLabs. For those of you who are, new, basically we are Series A startup focusing on building multimodal video understanding technology. This is an initiative that we've been hosting over the past 2+ years or so. On a weekly basis, we meet to discuss a variety of different topics, right? We have researchers coming and talk about newest activities happening in the research field in multimodal AI and foundation models. We have like developers who build our technology coming and give talks about specific projects, application that they build. And oftentimes we have like customer partners sharing the application, tutorial and guides using our platform and API. In some of the recent sessions, we have a good amount of developers from various developer events sharing their projects, building with our technology. Yeah, everything ranging from semantic search to like building models for privacy, real-time understanding, application of TwelveLabs video models in education, healthcare, productivity, etc. And that's the case for the session today. So we have 4 very exciting presentation from basically all different students who got a chance to try out technology in recent events. So the first group is Bayu Awikasonko, Fachri Karitiman, and Mochamad Kari. I believe you guys are calling from Indonesia, so it might be pretty late in the evening for you guys. But they will present their project called Qlassroom, which is a winning project at one of the recent virtual hackathon hosted by our partner Qdra. This is an interesting application that looking into turning Zoom summary recording into like multimodal knowledge assistant, leveraging different modalities from speech, video, image, document, and slide. The second group is going to be the NewsCap group from Pranav, Ryan, Josep, and Bryce. So they built NewsCap during the recent HackGT hackathon in Georgia Tech. This project is a way to fact-check videos in real time. It's an AI-native video player, making valid research-backed information more accessible than ever. Very nice combination of using TwelveLabs with, I think, EXA, right? That's the name of the research that you guys use. The third presentation, also from HackGT, from Akash and Devland Beasley. They will present PropSage, which is a video-backed prop insights application that stitch real-time real game videos to prop markets, so you can see the evidence and act fast. So the domain here is spot analytics, and they leverage TwelveLabs in conjunction with Perplexity. And finally, we will close out the webinar with Umer. He actually a second-time presenter, calling from Canada. He will present his project called Tidier, which is a video summarization application that let users upload their own video from their application and gives them a montage of specific things that they want from each video. So yeah, very nice use cases on highlight generation, and I'm excited to see. So with that, I'll just a quick final slide on the logistic of the session. For attendees, feel free to send your questions on the Zoom chat, and we have a short 2 or 3 minutes Q&A for each of the presenter group after they finish. So with that, I will stop sharing my screen, and I let the first group, the Qlassroom group, to go ahead and start your presentation.
Okay, thank you for the opportunity. Let me share my screen.
Okay, so we're going to present our projects, which was built for Hackathon Qdra 2025. It's called Qlassroom, a multimodal learning assistant. Next. Okay, so the main problem we are addressing start with the limitations of current Zoom or meeting summary tools, because most of them only rely on the text transcripts, which means they completely miss the visuals and contextual informations. That's actually very important in learning videos. And also, educational or instructional videos usually contain multiple types of content, like speech, slides, and visuals. But these are hard to search or analyze together because they exist in different formats. And finally, when we deal with large collections of videos, valuable insights end up scattered across audio, video, and documents. And without integrations, it's really difficult to retrieve or understand the full context of what's being taught. So to solve this problem, the idea is to build a multimodal knowledge assistant called Qlassroom that can actually understand not just what was said, but also what was shown and presented during the lessons. By integrating multiple modalities, including speech, video, and slides, Qlassroom can achieve a deeper understanding of content and provide more accurate, context-aware explanations through semantic search. In short, it turns learning videos into an interactive and intelligent knowledge resource rather than just recording. Next. So here are some tech stack that we use to build this project. We use a combination of several technologies such as TwelveLabs, it's for video and audio processing, Cogni for knowledge graph constructions and text embedding, CrewAI as the reasoning agent, Neo4j and Qlassroom as the knowledge storage components, and also Python is for the programming language.
So this is the system architecture of our project, where our project has two main features. First is create knowledge base and user query. This is the architecture for create knowledge base, where user can upload from various type of file, like video, document, and image. Input files first are stored in the Google Cloud Storage. If the input is video, it goes through the TwelveLabs pipeline, where TwelveLabs will generate video and audio embedding, which already include feature like OCR, speech transcription, object detection, and other feature. And this embedding is stored in the Qlassroom under the video and audio index. And if input is document file, we will extract the text and the image, where image from document and directly uploaded image goes through the same process, which is sent to the LLM to generate the text description. After we have all the text content, both from extracted text and image description, everything goes through the Cogni pipeline, where Cogni will build a knowledge graph stored in the Neo4j for extracted feature like relationship between entities. And Cogni will also build text embedding that is stored in the Qlassroom under index text for semantic search. Next. And then this is the architecture for user query. User can query using text or image. If the input is image, it first processed by the LLM to produce the text description. And then the text query is sent to the CrewAI agent, which decide which Cogni model to use based on a question. This CrewAI agent will analyze the query context and select relevant model. This model will determine which knowledge base is used to get relevant chunk. Like for example, a graph model for relational or reasoning-based question can query relevant chunk from Neo4j, and traditional retrieval model for document, text-based, video, or audio-related question can query to Qlassroom index text or index video and audio. This one also determined by the agent, or a combination of multiple model for complex multimodal reasoning. And then the system will query to the selected knowledge base to get relevant chunk. And then this chunk will send to the LLM to generate the final answer. And the final answer, if the final answer has relevant media like image or video, the system will retrieve the media from the Google Cloud Storage and display them alongside the final answer. Next.
Okay, the next is demo. Hold on. First, in case 1, we use input text to determine if it the result or not. And the input text, we can see the effectiveness and efficiency. The system will process that, and then the generated output will output the summarization and video or slide. As you can see here, we see the second at 54, and we see the effective and efficient. So the results are matched with the input text. In case 2, we input query image. Query image is used for generate the input text here, and then the rest is same. The Crew AI will process the input and the result are generated. And the last is show and update knowledge source. So the source can update it with your own data, and then it's stored in Google Storage, and the video and slide will start at the Kidron vector space. What's next? First, we aim to reduce latency so the system can respond faster and provide a smoother user experience. Second, improve the user interface to make the experience more intuitive, engaging, and visually appealing. Finally, we want to add new features like authentication and personalization to support individual users and secure access. That's all from us. Thank you.
Awesome. Yeah, thanks for the presentation and the demo. I think it's a very nice illustration of how to use our embedding technology in conjunction with agentic workflow, vector database, especially the combination of text embeddings and image embedding, etc. Yeah. Any question from the audience on for Qlassroom team? If not, you can put on the chat so they can answer it asynchronously after the fact. Maybe just one question from me. What is the most difficult technical challenge throughout the architecture that you guys have to deal with as you design the application? Anyone want to answer?
The hardest technical, right? I think when we want to architect all the architecture, like when we start this project, we want this project to use multimodal, so the architecture has to match with our thinking. So we use all the tools here, and we learn all about this, and it's hardest than our thing before.
It's basically a learning curve, right? Learning to use the technology and make it fit for your project.
Yeah, right there. Like this.
Got it. Okay. Thanks for the first presentation. Yeah. So let's move on to the second group. So I believe it's Bryce, Pranav, Brian, and Joseph. You guys want to share your screen and present NewsCap?
All right. Well, I'll get started. Hi, everyone. We're excited to present our project, NewsCap, and it's a tool that helps users combat misinformation. So we're using video understanding to combat misinformation. And here's our team. I'm Ryan Zhang. I'm a fourth year CS and math major at Georgia Tech, and I'll let everyone else introduce themselves.
Hi, I'm Bryce. I'm a fourth year CS major as well.
Pranav. Sorry. Pranav, fourth year CS major.
I'm Joseph, a second year comp major.
And so I'll just start by talking about our hackathon experience. So drawing upon Bryce's and Pranav's previous experience at hackathons, our first step was to talk to as many sponsors as we could and generate ideas by asking what they wanted and what we could do that fit those requirements. So our first night, we brainstormed some ideas and thought about things like developer tools, medical technology platforms to centralize personal medication info. And after several hours of pondering and discussion, we realized that an idea to combat misinformation and the Trump speech in particular made us think about the nuance in his speech. So, for example, in the Tylenol, the research that linked Tylenol to autism, the researcher himself stated that the research was inconclusive and more needed to be done. So we thought that analyzing the videos themselves and allowing users to identify the claims made in the Trump speech and finding the sources to back them up would help them understand what's really going on behind the scenes. So after we finished this part, we just divided the responsibilities and started coding. And the problem was that over 50% of adults get their news from social media. So Instagram and TikTok might have fine misinformation and try to check the validity, but we'll get into this more later. And very few people actually check the validity of the information they consume. And the other issue is that most users don't find alternative sources, and it's quite exhausting actually. And so here you can see on Instagram, you might have a fact checker A, fact checker B, talking about whether this information is false or correct, but most people don't really look into this, and the sources that it provides may be false.
Yeah, so our solution to this was NewsCap. So NewsCap works by first processing YouTube links. So the user puts a YouTube link in from the front end, and using these YouTube links, it finds all the claims made in the video using the TwelveLabs API. And from then on, it finds the sources for each claim using Exa and compiles research into like an approximation of how like accurate that claim is. And this enables the user kind of to dig deeper into the research found and kind of like explore whether or not they can really trust this claim. So, and on the next slide, we have a demo of the actual app. So to start out, the user puts in a link into the search bar. So can you skip past that? And after putting it in, they can send it. Right. So now the backend is processing the link, and once it's finished processing, you'll get a list of all the claims and answers in a second. So yeah, so here are all the claims. So you can see like you can like categorize what the claim is and also like how like correct the actual API thinks it is. So and based off like the actual it bases these off these sources. Additionally, we also have flagged moments. So this is the next tab, and this kind of like tells you where in the actual video that the user made or the content made the claims. So if you click on the actual like moment, it'll skip to that point in the video. And finally, we also implemented a Cedar OS. This was another like hackathon sponsor at HackGT12. And then using like, Cedar OS, we can kind of select like specific claims and moments, and using these like claims and moments, the Cedar OS like AI will kind of help you dive deeper, and like it has context based off the actual result of the Exa like research. So it'll tell you a lot more than what you can just see in the current like front end. So it bases all of this information off what we found like in our research. Right.
So we split our architecture up into two separate segments. We have a front end that basically takes the URL and passes it to the back end. And the back end that's doing a lot of the heavy lifting, which is basically where we call the APIs and send the results and the scores back to the front end, where it can then display it, flag the moments, show the user what's going on. Next slide.
So yep, this is how we divided it up into microservices. We were trying to go for a balance of making it easy to develop on, as well as getting it done within the time that we had allotted. So here we can see the different flow. First, the front end sends that YouTube URL to our processing and research microservice. And then this YouTube URL is passed to Rapid API, which converts it to an MP4. Then that MP4 file is turned into a publicly hosted URL, so we can feed that to TwelveLabs, and that's passed to our second microservice, which then deals with generating those highlights and finding claims using TwelveLabs, and then that gets passed back to the research microservice, where it then calls the Exa API with each of those claims, and then receives back the sources and scores, and then returns all of that to the front end. Here is our tech stack. One of the cool things that we ended up using for the first time was Exa. And Pranav, if you want to talk a little bit about our justification for using that over maybe another tool like Bing or Perplexity.
Yeah, so fundamentally, they kind of do similar things, but the gist of the reason we use Exa is because they additionally have kind of like an easy way to take the results and format them in a way that I guess is like understandable for the user. So like you can generate things like scores and such with their models rather than having to basically apply your own model on the back end, which allows us to offload some of that heavy lifting.
But yeah, so here's a little bit on how we use the TwelveLabs API. This is kind of abstracted code. But first we create that index, and then we create the task and summarize highlights. Basically what we do is we create these highlights based on a specific prompt criteria, and then we build summaries of those, and those summaries are actually what gets passed to Exa. Additionally, we pass the timestamps of these highlights and summaries as well. So here is actually the prompt that we use to get the highlights, if anyone is curious. We actually found that this worked really, really well. So yeah. So some of the future applications for this involve like real-time debate fact-checking. Oftentimes when candidates are on stage debating, it can be tough to fact-check these things in real time. Additionally, the fake news alerts on social media are largely annoying, or sometimes don't capture a lot of the intricacies of the post. Like sometimes you'll see these fake news alerts on joke posts and stuff like that. A tool like this would have the intelligence to know that, the context around it. Additionally, allowing for interactive deep dives on video information is something that we want to integrate. So right now, it's a one-step process to identifying all the different claims made in the video. It would be nice for users to also be able to flag certain moments. And we also want to start dealing with circular citations. So something that you may have noticed in the video is some of Trump's claims were considered factually true. And this is because the research that was done had pulled a lot of sources from whitehouse.gov. This is not like inherently a problem with this specific method, but is something that everyone should take into account when they're doing any type of research. And so being able to find where the flow of information is coming from would be a good next step to validating that information is independent and true.
So some more next steps that we're thinking of after this project. One of the big ones is that we want to actually combine the power of both the Marengo and the Pegasus models. So one deals with more like embeddings, and the other one is a deeper sense of like visual understanding. We kind of want to use the heavier models where possible and the lighter models where we can, and then that way we can handle, for example, like really long videos much better. We also want to allow users to flag their own moments for a deeper analysis. Right now, we just go through the claims that have been automatically generated, but Exa also has things like deep research agents in their API, and these can be really useful and understanding the nuance of items like circular references. And then lastly, we want to enable search multimodality in the future too. So since we have the timestamps in the video where a certain claim is being made, some of the nuance is lost by basically just like transcribing the audio or using the transcription given by Pegasus. Ideally, like in the future, we could directly give the video to the search engine too and be like, hey, can you look up this figure for me, for example, and see if it matches anything else that's publicly available online.
And yeah, any questions?
Awesome. Yeah, thanks, guy, for prepare very detailed slide and walk through the demo. Yeah, if any question from the audience, feel free to put that on the Zoom chat so they can answer them. Yeah, in the meantime, well, there's one question on the chat, if you want to answer that one first. What is the consideration to chunk the information fact checking from video?
So essentially what we do is we look for any times that somebody is trying to make a claim or pass off facts, and then all of those get fed to the research agent to actually dig into all of them. And then that score is calculated based off, like the accuracy is based off of if the majority of sources are kind of backing it up or not.
Yeah, so hope that answers your question. Personally, we've been exploring Excel as well for like some interesting workflow. To your point about deep research, right? They also have a very nice MCP server that was published recently. We've been trying some novel ideas of using like TwelveLabs MCP in conjunction with Excel MCP just to do exactly the workflow that you guys did in this application, right? Video analysis, and then using that to provide citation, follow-up, links, etc., to enhance like the content, right? Yeah, so overall it's a nice product, very good experience. Maybe just one question from my end before we move on to the next group is the slide about microservice architecture design. Can you zoom in more on that and like talk about like the technical challenges of ensuring each of the microservice speak to each other in a reliable and like performance wise, like how you make sure that like all the services are functional and like speak to each other.
Yeah, of course. So the big reason that we did two of these microservices instead of just one singular like Dockerized app is so that we could work on these parts independently. And so like we each had our own domain. Pranav was working on the research part of it. I was working on the Labs. Joseph was working on front end, and Ryan was dealing with the video processing. So this allowed us to kind of work independently on our different parts, I guess easier than if we were all trying to work in the same container. The reason that we didn't divide this up into like 3 microservices, having one that was the video processing, one that was TwelveLabs, and then one that was research, is that we just didn't think it was necessary, and we took the time savings here by simplifying it a little bit. Do any of you guys want to add anything to that as well?
I think that's mostly accurate. Like the intention, again, coming at it was just how do we get the most throughput from our team as possible right at the start? And if you can minimize collisions within the team by splitting it into different services, that's really good. And then like performance-wise, of course, for the actual demo right now, everything's running on the same computer. So we don't have a lot of overhead in terms of like, I would say transmitting video and other such things like that. Whereas like if these were on like different servers, you might want to take more of a consideration of that.
Yep. Awesome. Yeah, I think that's the only question I have. I'm curious about it. But yeah, overall, like it makes sense, and some of the ideas on like putting on multimodal enhancement to make it even better, and circular citation. I think those are very nice idea, like just to enhance the quality of the sources and the report being generated from Excel. Great. So yeah, let's move on to the third group of the webinar today. So PropSage group, Akash and Devland, you guys ready?
Yeah, we're ready.
Yeah.
I'm gonna go ahead and share my screen. So quick introduction. My name's Akash, that's Devlin. We're both third year Georgia Tech CS students. Devlin, do you wanna start us off?
Yeah. So yeah, our third group member couldn't make it, unfortunately. But yeah, our project is basically just PropSage, and it combines video intelligence with sports analytics. We did the prize picks track for Hack GT12. And so basically going into the project or going into the hackathon, we just wanted to explore some ways that we could combine video intelligence with like sports, because we all are interested in sports. So yeah, we wanted to make it like more visual and interactive and like more digestible for the common like sports fan. Like we wanted to make an application that could like bridge data with sports and make it like easily viewable for like anybody that just like enjoys football or basketball, any common sports like that. And yeah, the third line there, we wanted to democratize professional grade prop analysis. We just wanted to make like prop lines from a lot of these sports betting apps more coherent for people that use these kind of apps, because any app like Prize Picks or FanDuel, it could give you like a specific prop line, but you wouldn't really know why they have that line set that way. And that's why we created PropSage, just to bridge that gap. So yeah, like sports apps usually they have like the player name, then over under like 2.5 touchdowns, over under 30 points, but they're not going to show you like why they have it set that way, because obviously they want to turn a profit by making users take these lines. So we just basically try to develop an app that would kind of turn the tables on a lot of these like big corporations. We wanted to enable users to see like the true lines, or enable users to see like more accurate lines, or see the reasons why some lines are set the way they are. And yeah, a lot of sports analytics is just like completely taken over by spreadsheets, which are just like not viewable. Nobody's gonna look at a 1,000 or 2,000 line Excel spreadsheet and be able to like digest that data for like a particular sport. So we just wanted to take some of these models, use some video intel on them, and just turn them into something that a common user could look at and use. So yeah, we just kind of wanted to level the playing field in that sense. Like Prize Picks, a lot of these big companies have like data models that aren't viewable to the general public. And so we just wanted to give like sports bettors a little more power in that sense by giving them transparency, and also letting them just like have new opportunities to see where they want to put their money at.
Okay, and then I'll go ahead and do a live demo. So here was the application that we created. So for example, when you look at the app, you'll see top edge opportunities, and then you'll see games. So you can see Gunnar Stockton, that's UGA's QB, and the market will say that the line that they're drawing for passing touchdowns is over under 1.5. We think that the fair market line would be 1.9, and so we're saying that the line that we think should be higher than what the market is saying. And basically by utilizing TwelveLabs API, we can actually query now mute that. We can actually query our index, which we have like a lot of sports footage in, and then here you can see a clip of Gunnar Stockton throwing a touchdown. And then also this is where like the Perplexity AI comes in, is that we hit the Perplexity API to generate like a news report on Gunnar Stockton and why we think that his edge should be higher than 1.5. So you can see here that his red zone TD rate is 42% of drives, which is higher than the team average. The Alabama defense, which is the team they're playing against, has been allowing 1.7 TDs per game in the last 4 weeks. And then you can see more and more. And then there's also some video analysis. So if you want to look at a different player, Haynes King, Georgia Tech, they think that the fair market line would be 235.5, but we think that the fair line would be 252. And here you can see video footage of Haynes King, and he'll throw a pass here. So essentially, when you're betting on DraftKings, Prize Picks, FanDuel, all you'll see is a player's name and a line, and you won't have any like they won't tell you any news, they won't tell you any analysis, they won't give you any evidence. It's just up to the, I mean, they're doing that on their end to draw those lines, and they're running large statistical analysis to draw those lines, but you won't see that as a consumer, and that we were trying to break down that opacity, that layer, and just be completely transparent with users. So going into how we actually calculated it, just explain the tech stack quickly. Our front end was a Next.js client, and then our back end was Node.js, and we deployed the front end with Vercel, and the API server was deployed with Railway. And basically, the way that it works is that we'll get a prop line, and we hit a few APIs for the to get sports info, sports schedules, prop lines, and then we will hit a TwelveLabs API, which has like our sports footage. It'll query some of that data and then form analysis on that, and then we'll also combine that with some of the data we get from Perplexity, and based off of Monte Carlo simulation that's coded in TypeScript, it'll determine a fair line, and it'll show the user or the consumer exactly why we do that, along with video evidence. And yeah, that's pretty much our app. We developed it for HackGT like 3 weeks ago. Considering next steps, the main limitation that we hit in developing this was that sports footage, sports betting lines, historical sports data is something that's extremely like safeguarded. It's something that you have to pay a lot of money to be able to attain. Like getting live NFL data is probably like, I think APIs are charging like $1,000 a month, because this is a market that's heavily already saturated with big corporations that try to draw betting lines like Prize Picks. So a limitation of our application was that we were only able to do it on the three college football games that happened that weekend, and that's because we were able to watch those games and actually get the clips ourselves, because game footage is something that's not free. You can't get it, and we developed our application with like no budget. Another thing was that sports betting prop lines are something that you can't get without paying as well. So we had to like manually go into like Prize Picks and get those lines, and then draw our fair lines based off of that. So for next steps, it would definitely be to expand our application to cover all games, cover not just college football, but NFL as well, and maybe other sports. And then if we can get enough footage and get enough data, basically, on prop lines, on player stats, on game footage, then we could expand this to be a real-time application. We are seeing prop lines move in real time. But that's essentially our whole project. Please feel free to ask questions.
Awesome. Yeah, I think it's a very cool utilization of a technology for a very concrete and real world use cases of spot analytics, spot betting, right? Let's see. I think you briefly mentioned you were using some Monte Carlo simulation for like the fair analytics. Can you explain it in detail? What exactly does it mean?
Yeah, essentially it's like we'll take the it's like a statistical analysis, and we'll take like the expected value, and within like using historical player data, whichever one we were able to get, it's like within 2 standard deviations of that, and then we'll it's coded in TypeScript in our backend, and it'll try to compute that like within 2 standard deviations of whatever their like average is. That's like wherever that falls is where we'll put that prop line. But another thing for moving forward with this was that hopefully in the future we would use like some sort of LLM or MLP rather than like a statistical analysis. We're using like an LLM analysis on the video data to be able to be like, oh, this is that would take our application another step up as a limitation.
Thanks. And as for the usage of Perplexity, I think you briefly demoed. You basically using it to gather real-time information about specific players, right? Like the statistical performance of that player in recent games, right? What's your prompt look like for the API to return those answers?
Yeah, so our prompt, it's pretty simple. It's like, what is this player's we'll query Perplexity, and we tried a few different ones, and we'll see what's their compare their historical play analysis, like how much find news sources for how this player has been playing for like this season, and then find, you know, within the last week how many, you know, if they're injured, how they've been playing, like have they been scoring well, and then also compare that to how the our Perplexity API will also query, our prompt will also be to ask how the other team has been scoring. So for example, like in the Georgia-Alabama game, I showed you that it also showed that Alabama had been allowing touchdowns, which also contributes to how our prop lines are drawn. But yeah, basically just the player, it's how he's been performing, how their team has been performing, and then how the opposite team has been performing.
Got it. Perfect. There's a question in the chat. Do you want to answer it quickly?
Yeah, that's another. Yeah, that's a good question, and that is a limitation that I realized in our app, was that the accuracy of it is definitely to be questioned. Due to what I mentioned earlier, is that we're able to get news reports, we're able to get some historical data on players, and we're able to analyze video footage from the game happening and be able to say like how well that player is doing. But because we're not able to get, if you want to get, you can't get like all NFL footage, and you can't get all college football footage. We're the only footage we were able to attain is the footage that we could get that weekend, and that's a big limitation in the accuracy of our application. If we were able to get a ton of footage and train an LLM on that footage, and then be able to do that to influence prop lines, that would be great, and that would be ideal. But that's just something that like we financially didn't have, like we were limited in. So that's why we chose to do a statistical analysis, because that way we can just get get historical data and and get the average of how that player has been playing, and then not have to, you know, get a lot of sports footage.
Great. Yeah, overall, I think this is very, very awesome and exciting application. The front end is also very nice. Like the module to pop up and to display the video player as you click into each of the player. Make it a very nice and easy consumption, detailed information of the player themselves. Great. So I think we can move on to the last presentation. For the last 10 minutes, Umer, you want to share your screen?
Yeah, can you guys hear me?
Yep, we're here.
All right. Okay, so hi everyone, my name is Umer, and I wanted to share with you guys a project that I made with the TwelveLabs API and other technologies that can serve as a real use case for people, called Tidier. So first, a bit about me is second year I'm currently attending McMaster University, my second year from computer science, and I'm passionate about building tech that makes people's lives easier. So the problem I faced was that I came back from a vacation not too long ago in London, and I wanted to look back on all like the footage I took of the London Bridge, but I did not want to deal with the hassle of going through every long video just to get the part that I wanted to see. So I figured I would use TwelveLabs to assist me in creating a solution for it. So I would say the general problem statement is reliving the best parts of past vacations is difficult because the moments I care about are scattered across hours of footage. So the solution would be to solve this. I built Tidier, so which tidies up your cluttered videos. The app searches across all your videos and automatically generates a montage of the exact moments you want to see. So instead of scrubbing through all your videos, you simply describe what you're looking for, whether it's monuments or I don't know, views of the lake. And Tidier finds and stitches those scenes into one montage. So with just one click, your scattered clips become meaningful, shareable memories. So just before the demo is like about the architecture. So the user uploads any videos that contain what they're looking for, and it is uploaded to this Spring Boot server that calls the TwelveLabs API to index each video and store it for later use. So if the videos are not MP4, then FFmpeg, which is like a command line tool for just convert anything you want to do with videos, it simply converts the video to MP4. So the user then selects what videos they want for the montage, gives the topic and title, and clicks generate. So after clicking generate, TwelveLabs using Pegasus searches for the topic in each video and gives the timestamps to FFmpeg, which then uses them to trim each video and combines them. The Spring Boot server then serves a montage to React, which would display it to the user and we can download. So just some notable features is real-time processing notifications. So like while you're waiting for the montage, Tidier updates you on each step of the process from extracting the timestamps to trimming and then to combining. Video stitching using FFmpeg. This is more efficient than using traditional video editing platforms because FFmpeg is a command line tool that can trim, merge, and process videos without re-encoding. So that means it works much faster and doesn't lose quality with each edit and uses far less CPU power. Third is video upload and storage. AI video metadata is uploaded to Postgres. So is uploaded to a Postgres server. So you can upload a video and decide if you want to use it now or later. And last is downloadable montage. A montage that Tidier makes is easily downloadable. So it's a seamless user interface. So I'm just going to share my other screen. Actually, wait. Can you guys can see, right?
We're still showing your slides.
Yeah.
Okay, no.
Okay, yeah. So
Yeah.
it's supposed to be like a mobile app, so I just have the mobile version. So let's say I have all these, I uploaded all these videos previously. So all these are just different vacation videos. And I want to see the London Bridge. So I give the topic here, and then I want to title my montage, I don't know, London Trip 2022. And I select the videos that I want the montage to be made from. So I have one video of me on a boat and then one video from a castle. So I select it here and then I just click generate and then starting montage creation and then extracted the videos. Yeah, combining. Yeah, so this is one video. This is the actual video is like a minute long, but this like 1 5-second clip is what I care about. So there's a London Bridge. And then this is the second video, like of me on the boat. So that's like the London Bridge. So it actually like it took the timestamps and then combined it into one montage. So yeah, a few things I want to say is that so just some design choices that I wanted to highlight. I chose not to use the Node or Python SDKs that the TwelveLabs teams offers, which are great, by the way, because I wanted to work directly with the raw API. The integration turned out to be just as smooth, and it gave me full control over like all the request formatting and the error handling, response parsing. This made it easier to implement any custom features like timestamp based trimming and course of montage creation. I also used Spring Boot since much like the Java backend, since much enterprise software is built on this framework. And I wanted to test whether the service could be easily integrated into enterprise level systems, and it proved it was able to do that. I'll just show you the code real quick. It's on another tab. Yeah. So this is like the montage service. You have, so it's just creating each montage. The actual API call is used here. So I just analyze and then send the API key, all that stuff. And then, yeah, so it was pretty seamless. And then video, when you're uploading, these are all this is the controller, sorry. I'm at the service, so this is converting, uploading to TwelveLabs. So again, pretty easy to integrate the API. And yeah, so that was a code. And then I'll get back to the presentation. So yeah. Again, some future improvements and like ideas that I have that I do want to implement in the future. So one idea is like montage topic suggestion. So which would leverage the TwelveLabs API to automatically summarize each video and suggest relevant topics for the montage, making it easier for users to organize and select clips. So like let's from previously, like I had all those uploaded videos and I want a montage, but I don't know exactly what the topic is. So I could use the TwelveLabs video summaries. I could build something that goes through all the summaries and can generate a list of topics that I would want. Another feature is another improvement is a smart montage library with topic-based sorting. So all the user-generated montages are stored in a personal library and can be filtered or searched by topics. So like beach trips or food tours or family moments using tags generated from the 12-hour video summaries. So yeah, together these features would make it faster and more intuitive for users to make their montages. And yeah, that's all. Thank you. Any questions? I guess might have.
Perfect. Yeah. I think we got like about 2 minutes left, but for the session.
Yeah.
Maybe one quick question I have is your choice of using Java as the language for this application? What's the benefit, like practical benefit of using this compared to
So
Mhm.
it's like used a lot in a lot of enterprises. So like it's easily scalable because of its like object-oriented nature. So if I want to build on this, I would be able to. And it's just something I honestly just wanted to try out, and just wanted to deal with the raw API and see how I could build with that. And yeah, and it turned out to be a good process.
Perfect.
Yeah, is any other questions or?
Did you encounter any challenges of working with FFmpeg for the
Sorry?
Working with FFmpeg, did you encounter any
Oh.
technical challenges of like stitching clips and combining them?
Oh yeah. So it's a command line tool, so I had to like learn how to use like, command lines without actually being in the terminal like from Java. So that was a bit weird, and I had to like learn all the different coding types, like all the encoding types of the videos. So that was definitely tricky. But honestly, like 12labs, like it just gave the timestamp. So after I figured all that out, I just feed the timestamps into the command, and then it stitched the videos for me. So that was definitely a challenge of figuring out how to like convert to MP4 and stitching and combining. But yeah.
Yeah, I'm just curious. This is like the common charges that everyone dealing with video have to encounter. Right? Because it's not like traditional like library or package that you can easily like.
Yeah, it's not like it's not like you can't code it. It's like a command line kind of tool. But there's benefits to it. So yeah.
Okay, I think we're out of time. But yeah, thanks again, Umer, for walking over this application. Very nice demonstration, personal use cases. I like the mobile app aspect as well, where you try to incorporate into the nice device design. Yeah, so I think we're out of time. Thanks everyone for preparing your presentation today and meeting with our technology. Webinars recording should be available by early next week, so be sure to share that on YouTube, and you guys can post it and share with your friends and social media, etc. And again, yeah, we run this virtual session on a weekly basis. So yeah, stay tuned and keep posted with what's going on with our TwelveLabs community for future session. Thanks everyone, and hope you enjoy and have a good rest of your weekend. Cheers.